Hi, good morning all. Hope I'm audible. Welcome to RK Performance Zone and greetings. I'm Radhakrishnan Prasad, the trainer of this program. Okay, so today we are going to talk about what is the training is all about, why you have to opt this training, and what is the end result of this course. Basically, before I start that, I would like to tell me something about myself. I have total of close to 12 plus years of experience in core performance testing, performance engineering, involving in all the different phases of performance testing life cycle, performance engineering life cycle. Okay, I was a part of application performance management, working with many of the tools. So I have been using various tools with different versions of HP, Micro Focus Load Runner, then Apache Tomcat, Gatling. I was also a part of Locust. Okay, and I was part of Neoload for some time. And from the last few years, from the last 5 to 6 years, I was into core advanced performance engineering practice, where we are doing performance validation, doing some assessments, and we are also doing something called performance tunings on all the different web app DB servers on multiple environments like on-premise environment, cloud-based performance testing, then containerized environments like where you have everything sitting on Docker, Kubernetes, Red Hat, OpenShift connected to multiple clouds. And most importantly, moving all of them from monolithic to microservices based architectures. In addition to that, we are primarily doing performance testing on all the database migrations, data center movements, which is also called a database replication performance testing. Okay. So that is all about myself. But coming to this course, when I talk about this course, right, we have a lot of different things before designing this course. What we've done is we have taken inputs from approximately 300 plus performance testers who are not actually performance engineers. Understand what is the current actual requirement going on with all the services based companies, multiple customers, product based organizations. Because if you see, many of the performance testers, right, they are still doing same traditional performance testing, gathering NFRs, identifying the tool that you have to use, then doing some performance testing, publishing the report by adding some suggestions and recommendations, merging the graphs to see what value is increasing with what, and copy pasting the graphs that are there from some APM tools, and you keep iterating this process until and unless you meet this SLAs. Okay, this is something very restricted, which is very limited to any performance testing team, because many of the performance testers or performance engineers, they don't get access to the web server or app server or database server to any of the environment, be it QA environment, be it dedicated performance testing environment, where it is referred as test environment. You don't even get access to such environments for taking heap dump analysis or something like thread dump analysis, or analyzing GC logs, or accessing a test database, taking AWR report, ASH report, ADDM report. So all these things have become impossible just because of your own security policies and security reasons that you have from the domain that you're working, right? Be it banking, be it Interpol applications, be it stock markets, trading, they have their own security policies where you don't even get access, where you don't even get the minimum configuration parameters that are set on a dedicated QA environment where you're actually doing performance testing. So if you try to understand what is this course all about, this course is basically, we have created this course in a way where we would be starting initially from the performance testing concepts, because if you take many of the associates from 1 year to 10 years experience, many of us still we actually get confused about what is HTTP, what does a HTTP request contain, what does a HTTP response contain, what is a cookie, what is a header, okay, what is a request body. When you send a request during the workload translation, when you, as a user, when you send a request to the server, what it is actually doing on the web server, app server, database server, most of the things like this, we many of us, we are not able to understand, because When we gather NFS, such information is not given, which is called workload translation, right? The weight of the transaction, the person, when you send a request, the percentage of the activity that it is going to do on web server, application server, and database server is what a performance engineer has to understand. And when he runs a test with different anticipated load conditions on the application, we will see many of the performance degradations where we need to optimize that one by one, and we have to achieve the desired performance, right? So if you look at the section 1, what we talk here is we will start initially with the performance testing concepts. We don't teach any of the tools, okay? This course is extensively for people who already have experience in any of the load testing tool, performance testing tool. You can use WebLoad, you can use Silk Performer, you can use IBM RPT, Neoload, Locust, you can use Gatling, any tool. So anyone having minimum of 6 months of experience in any performance testing tool are eligible to take this course. Okay, especially people more than 6+ years of experience. If you look at the common job descriptions across many organizations, you can easily see that particular difference. What is that is being asked for many of the product-based companies. Now the performance engineers were asked to take the hacker rank round, which is where the coding round is must. You get some assignment, you have to clear that coding round just because to understand code level errors, just because the teams are expecting performance engineers to explain well about the inefficient code by doing something called code profiling. Okay, we'll also come into that. So section 1 is going to talk about performance testing concepts, where we are going to start with all the different common performance problems that you see in Java-based applications, .NET-based applications, any applications. Comparing the functional automation, compatibility testing, then non-functional testing, security testing. Non-functional side, performance testing and security testing are so huge. I mean to say, it will take some 20 to 25 years to master it, because they have so many vast concepts. Performance testing is done on Java-based applications, all the client server applications, desktop applications. Performance testing is done on the API level, web services level. Okay, and we are going to do performance testing on SAP applications, Java applications, .NET applications, Siebel applications, Citrix applications, Salesforce applications. There is no end for performance testing. Every big vendor, every big e-commerce chain like Amazon, Costco, or Target, anyone, they're going to expect a minimum of 0.001% of performance improvement, which is going to save millions of money for them, especially while making a payment, while searching for a product. When a new change is implemented from the database or from the code level, to see everything is working as expected, performance becomes so expensive. And coming to performance engineering, performance testing on a cloud, microservices performance testing, then containerized performance testing, open source technologies performance testing, which means that the load testing tool is an open source one, database is an open source one, application server is an open source one. So identifying the maximum load it can handle with the desired performance is also a new trend, where it is optimizing, saving the cost of many assignments and other projects, right? So in the performance engineering, we're going to talk about all the common performance problems and performance roadmap, considering all the participants' experience, the domains, the experience, the protocol experience on what you have. We are going to help every associate who is part of this program with the roadmap, okay, from where to start, how to completely transform from performance testing to performance engineering, what are the skills required to do that are required for you to become a successful performance engineer, right from the coding. We don't teach coding, but what percentage of coding is required to get a job in a company like Adobe, McAfee, or MasterCard, or Visa, or something like ServiceNow, Salesforce, Meta. So there are so many companies like this where many of the performance engineers are missing the opportunity just because of lack of coding. No one, if you take 100 performance engineers, not even 2 to 3 people knows coding. right? So because again, if you take many of the customers, for example, from my experience, I have a customer who is assuming that I hired a skilled performance engineer. He can fix anything is what his expectation. Okay, that is how the business team has actually conveyed it without the actual uh, scenario that is happening from my side. So my customer is under impression that I'll be able to find out the bottlenecks from the database, application server, database server, web server, and is also assuming that I'm going to continuously monitor the CDN, DNS. I must be very well aware of the cache algorithms that are enabled from the client side, browser side, web server side, app server side, database server side, load balancing algorithms. Okay, identifying the wrong running queries, poorly designed schema. Okay, poorly implemented table partition across the databases, scaling, resilience, chaos engineering. So all these things are basically expected from any of the customer, but the role of performance engineer to not is actually not to convince the customer, is to make the business teams and customer to understand what exactly will be your role in any performance testing and engineering assignment when it comes to full life cycle project implementation. Okay, so for that we are going to tell you what is the percentage of coding is required, what is the percentage of knowledge in servers is required, what is the percentage of knowledge that is required from the network side. Okay, because performance engineer involves in client side performance testing, server side performance testing, user level performance testing. Then he or she has to know about load balancing algorithms, the different internal external components that are part of every uh, an environment in the underlying infrastructure, right? So when you send a request, it can be talking to multiple components. It can go to firewall, it will go to your router first, then it will go to firewall, then it go to load balancer, then it can go to multiple DNS or CDN, it will go to web server, application server, database server. If it is if it is an APIs, if it is using APIs, again you will have API servers in it, you will have a file servers in it. So a lot of internal, external components are involved. So involving and understanding the role and the activity that is being done on the request that you're sending is more important to find every performance degradation. Okay, so for that, roles and responsibilities of any performance engineer are now open. Okay, it is not that I have 12 years experience, I'll not do correlation, I'll not do um, parameterization, or I'll not write some custom code snippets. So earlier, if you take some 5 to 6 years back, there is a concept of having centralized teams where you have a test architect, performance test architect, then performance leads, then you have performance engineer, not performance engineers, performance testers. So where it is completely driven in a well-defined manner. So nowadays, if you take many of the projects, right, the emerging trend is having one performance engineer for one project, where you have multiple applications there, which the role is called sorry, IC, individual contributor role, where you will be taking part in end-to-end activities. You have to do workload modeling, you have to do capacity planning, you have to do NFR gathering, you have to identify the tools that are required for your load testing, monitoring tools, interpreting the results. Okay, if required, you have to implement something called CI/CD pipeline, where it has to run for every change. It has to run the test continuously on weekly basis, on bi-weekly basis. Automatically, it runs a test. It is going to publish a result. So something like that, you have an IC role where it is going to deal everything individually, where a performance engineer has to take care of every activity that is part of performance testing life cycle, performance engineering life cycle, and performance monitoring, which is referred as application performance management. Okay, so for that, we are going to talk about performance engineering life cycle. What exactly is performance engineering process? What is that concepts that fall under performance engineering process? So we teach all of that. And the section 2 will be talking about the Windows performance monitoring. So if you take all these WebAppDB servers, almost 85% to the 90% of the WebAppDB servers are installed on any flavor of Linux, Red Hat, CentOS, Ubuntu. But there are few applications like .NET where you have to use IaaS, Internet Information Services, as web application server, which runs on Windows Server machine, right? So for that, you need to do Windows monitoring, Windows performance monitoring. So if you don't have an APM tool, let's say many of the participants attending the sessions, they say that the customer is saying he has no budget to the performance monitoring tool. Either we have to use open source or either we have to monitor independently. In such cases, there are utilities like EventViewer, there are utilities like Perfmon, uh, which are going to help you to monitor everything. You can create alerts, you can create data sets, you can pull a report, okay? Something like this. For example, this is, you already have uh, IaaS server installed here. You can see, when you see IaaS server, you can also see the server where you can restart, where you can stop, or where you can start. You can also see the application pools where some of the applications are deployed here, right? So all these things you can go and just see what are all the things that are available from the server side. So when a server like IaaS server is already installed on a Windows server machine like this, so when you open Perfmon utility, it is going to give you all the details. Okay. As soon as you go to performance monitor and when you click on add, right? Until and unless you install IaaS web application server on your application, you will not be able to see all these .NET metrics. If you see the .NET metrics here, okay, like JVM in Java, you have .NET CLR. So you can also see .NET CLR, right? If you can see .NET CLR memory, it is going to talk about like minor GC and major GC and full GC. You have generation 0, generation 1, and generation 2 here, where you can see different metrics. Generation 1 heap size. You can see different metrics that you already have. And you can also see something like ASP .NET applications. You can see ASP.NET application, how many times the application has restarted, what are the number of applications running, request execution time, request wait time, so request rejected. All these things you can also see as soon as you create a data collector, something like this in the user-defined set. During the time when you run the test, right, you can create a new data collector set. Okay, if you say uh, something like IaaS server. Okay, when you click on next, you can create a performance counter alert. Where you click on next, you can add a performance counter, and you can go to something like processor. Processor is all about uh, the CPU utilization. So percentage processor time is the metric which is going to tell you what is the percentage of processor time. So if you say that as soon as it is going to exceed 75%, it is going to give you an alert. Okay, so save and close. When you click on save and close, whenever you're running the test, if you see this data collector set has been saved, you need to click on start. Once you start, as soon as you finish this test, you finish stop, right? It is going to give you a report like this. Something like a report like this, you're going to get a report like this. You see the report, it's going to give you the complete utilization like this. So something like that from the Windows, we're going to talk about real-time monitoring, how to monitor a Windows server. We're going to talk about all the metrics, what is processor right from the basics. For example, examining, investigating high CPU utilization, monitoring percentage processor time, percentage user time, percentage privilege time, what is processor queue length, what is percentage idle time. So everything will tell you till the hardware failure, till the problem where In terms of low CPU utilization, you can also see one logical processor which has failed because of hardware issue, and that is why the reason we are also seeing something called low CPU utilization, right? So we have number of cores, we have number of logical processors, difference between the physical disks, logical disks. Talking about all the CPU memory network related parameters is something which will explain everything. Okay, so here the title is missed, but the title here is performance monitoring is on Windows, and coming to the Linux, we're going to talk about the Linux servers, all three different flavors, Red Hat, CentOS, and Ubuntu. We're going to talk about some basic 140 commands that are required for every performance engineer. Okay, we'll give you that to practice, to have some hands-on practice on the Oracle VirtualBox, where you can install CentOS image. You need not have a separate dedicated Linux machine. You can create an Oracle VirtualBox on your personal laptop, and you can deploy a CentOS image to practice all these commands. Okay, and for all of us, there are some set of activities that we have to talk about: VMstat, IOStat. There are some main utilities which will help every one of us to take some reports from any of the Linux server. Linux servers, when I say Linux servers, web servers are installed, application servers are installed, database servers are installed. And I'll also tell you monitoring, how to do monitoring on Linux areas, okay? How to troubleshoot resources utilization. And also, when it comes to any of the performance, right? When someone is asking you what are the performance bottlenecks you identified, everyone saying that we have out of memory error, then we increase the heap, then we have seen high CPU utilization, we have seen high memory utilization, we have seen disk utilization, we have seen high latency. So in addition to that, what are all the other areas you're talking? If you take any application, right? I keep telling this point again and again because to give some clear understanding on what is that it's going to happen on the application side, on the environment side. So earlier there was no concept of client-side performance testing, right? When you're doing performance testing, you are hitting the server and you're going to get the response times of all these activities, right? And coming to, according to the recent survey that has happened by multiple vendors like Yahoo or other Google, then you have big vendors who has done it. So you have client-side performance testing. Someone is asking a question, are we covering SAR and NMON? Yes, we are covering SAR, NMON, everything as part of this course. Okay, we are going to tell you all the utilities, how to install the packages, how to install SAR, how to install NMON, how to pull the NMON report, everything we are going to tell you. Okay, so, and also we'll have the questionnaire part in the last, where you can talk a lot on these things. And coming to, I was saying about, client-side performance testing is a new emerging trend. So as soon as a page is ready, we are doing client-side performance testing using GTmetrix, using web-based test, using Lighthouse. We're doing client-side performance testing, Firebug, Wiselo, browser plugins. We have a lot of things. Then when it comes to testing the complete environment, so 15% of the bottlenecks, they happen from web server, 15 to 20%. 25 to 30% of the bottlenecks, they do happen from the application server. And all the remaining 50% of the bottlenecks, majority of them are directly from the database server. Okay, so database server should be always your primarily focus on the bottlenecks identification. Okay, you need to go tier by tier. And coming to the application server, when someone is asking you, have you ever have an experience in identifying deadlocks? Now your question is, which server are you referring to? Because deadlocks happen on application server and database server. So when I say I have seen high CPU utilization, again the question is, which server are you referring to? High CPU utilization happens on web server, database server, and application server. Resource contention happens on application server and database server. Logs are there on application server and database server. locks do happen because of resource contention. So understanding all of that would be your primary task. For that, where to start, what would be your strategical approach, why you have to learn all these things. You need to answer all the whys before you start your root cause analysis. Okay, so from here we are going to talk about the advanced concepts, where we'll talk about the Java performance engineering. We'll explain you what is JVM. Okay, the basics of what is class, what is object, what is method. Okay, the reason why we explain all these things is these things are crucial to understand which line of the code is problem. For example, you take a thread dump. In thread dump, why you take a thread dump? When you have a deadlock, when you have a resource contention, you take a thread dump, right? When you take a thread dump, how do you identify the root cause of deadlock? You are looking at the stack trace. What does a stack trace contain? Every thread dump will have a stack trace. Stack trace will go give you more in-depth information, and it will tell you the origin of the problem. It is going to help the developers and performance engineers from where the problem has been originated. What is the occurrence of the problem? Which line of the code is the problem? Which method, which functional is actually creating this deadlock? Is what you can see in the stack trace. So to understand the stack trace, to understand the heap dumps, to do some investigations on the heap dumps, you need the JVM architectural understanding. How different components in the JVM architecture are talking to each other is the most crucial part. Different types of JVM. We're going to talk about JVM architectural internals. This is where you have runtime data areas, which is called method area, heap area. A lot of things are there. Okay. So when I say all these things, we are mainly we're drilling down something like heap memory. What should be your minimum heap? What should be my maximum heap? How many heap dumps do I need to take? What is the frequency of the heap dumps that I'm taking? How should I take my heap dump when I'm seeing a memory leak or out of memory error? To understand all of that, you need a understanding on the you need understanding on the JVM. So detailed application, sorry, detailed explanation on the JVM heap structure. So how the memory areas are modeled, what are all the JVM flags that we can use to increase, decrease the size of young generation, old generation. When I say young generation, I'm talking about the Eden space. I'm talking about the multiple survivor spaces. Then I'm talking about old generation, which is also called tenure generation. And the other part of the area is called non-heap memory, which is also called permanent generation till Java JDK 7, which is now replaced by Metaspace from Java JDK 8. Okay, so and most importantly, inside Java, after the heap, you need to understand the different types of garbage collection techniques. How does the GC work? What is the stop the world events? What is the high GC past time? How they are impacting response times? How they are increasing all the resources like CPU, memory, and hard disk and network on the application server? How to optimize GC? When do we need to take GC log? And what is the importance of different GC algorithms? Types of GCs you have, right? Minor GC, which is going to happen on young, major GC, which is going to happen on old generation, full GC, which is going to happen on both heap memory and non-heap memory. Okay, so the frequency of minor GCs, the frequency of major GCs, full GCs, then also understanding the importance of different GC algorithms, right? Simple question would be, what is the GC algorithm that you're using? You're saying that I'm using G1 GC algorithm in my application. Can you tell me one reason why you're using G1 GC when you have 7 to 8 GC algorithms? You have serial GC, you have parallel throughput GC, you have CMS concurrent mark sweep GC algorithm, you have G1 GC, garbage collection, garbage first algorithm, which is also called garbage first. Then you have epsilon GC, then you have Shenandoah GC, then you have Jet GC. All these GCs are GC algorithms, and each GC algorithm that you are selecting for your application performance testing will have different impact on the application performance and also on the overall system performance. Okay, I'll also tell you why you are selecting G1, GC when you have other GC algorithms available. Okay, we'll go in deep into that. Okay. Someone asking Mayank Sharma, you have some question, you can ask if your mic is working so that other people would understand.
What I'm asking is, what would be the duration of course? First, second, how many weeks of how many hours in a week of training are we expecting in this course, and then how many hours we would have to spend on our own to, match the objective of this course? What would be the durations like?
Basically, we're teaching everything from Monday to Friday. This time we are actually planning for Monday to Saturday. The reason is because many people are actually trying for a very serious job switch, and we are taking 45 sessions. Okay, 45 sessions overall. We because the time why we are taking 45 sessions is we are for example, if you take a Java application, we have a sample application where we would be showing the end-to-end installation configuration setup of Apache Tomcat, then application deployment where we are connecting to MySQL database. We are making the participants to create their own application deployment setup on their personal laptop. You can run a test with 50 users, and you can take multiple heap dumps, thread dumps, GC logs, all these things here. But the same thing applies to .NET. We have a sample application where you can install it on deploy it on IIS server, where you'll have so much of data like SQL Server database. Okay, we are connecting to that, and we are making everyone to know about every server installation right from the line number one, application deployment, profiling. Everything will be happening on something like a real uh, simulated work environment. Okay, so it would take 45 days, 45 sessions, and we expect the participants to spend at least 1 hour on what we are teaching, because I'll tell you why. So every training program, we are going to help something like this. Every session would look like this. Okay, you're going to, if you take the first session, we are going to show you this slide, and we are going to explain that topic on that day. Initial 20 days would be more on the realistic theoretical side. Okay, and as soon as we complete that thing, we are going to give you all the documentation that is required for you. Okay, something like this. If you're reading on daily basis, as soon as um, you finish the session, we'll also be giving you the recorded session along with the interview questions like this. We don't give any of the key for that, as we used to give a key, but when we are giving the key, right, people are restricting themselves to give only that answer which they see in internet. Okay, across multiple blocks. So likewise, for all the 45-50 sessions that we are taking, you approximately have some 500 plus entry questions which are going to help you to crack any complex interview. Okay, 1 hour a day from your side would definitely give you a very good opportunity with very huge pay. That is what we are seeing from the previous 8 batches. Okay, so it would take time. You need to spend a minimum of 2 months of time, at least 1 hour on daily basis, to make yourself updated with all these concepts. I mean, you will read all the content that we are sharing.
So RK, like daily after the session, basically you will be sharing the PPTs and as well as the learning, I mean the recordings and the references, whatever
Yes,
you.
yes, we'll be giving the recordings
Okay.
because we are not highlighting recordings because many of the people think that we have recordings so that we need not attend session. So I would strongly recommend all of you to attend the session to be more interactive, which will help your personal growth. So attend the live sessions, make the recording sessions only for your reference. Before going for an interview, open the recording and write it. Prepare your own handy notes, but don't rely on the recordings. If you're seriously looking for a job switch, look for the live sessions until unless if there is no possibility for you. If you're working outside India, then you do not have possibility. So if you're working in the morning shift, you will not have possibility. So what I'm saying is join the live session, ask as many questions as you want. Then even if you feel something is missed after completing all these 45 sessions, whatever that is required for your project assessment, we are also here to help you. We are also happy to help you on the content that you need in addition, or at least at a very high level, taking 1 or 2 sessions in addition. We are doing that for all the batches. Okay.
Yep. So RK, I mean, just to add on to that, right? So like, I'm new to the advanced performance engineering concepts, right? So like today in the introductory session, we were going quite fast, right? I mean, I believe we are into the individual sessions because we need to understand the concepts on a detailed basis, right? I mean,
No,
once
see,
we
the reason why we don't publish detailed content is because we are teaching many of the industry practices. We are sharing many of the sharing some of the sample heap dump files, thread dump files, realistic thread dump files, which already have huge bottlenecks in it. So such content we are not officially supposed to share. So when you go inside the course, right, we'll be talking about everything. If you can see here, you'll easily understand. Example, if you take 24, garbage collection introduction, garbage collection problems, garbage collection basics, or if you go to any of the other session, you can see top 10 Java performance problems is documented. Performance impact of GC and tuning is already available. GC algorithms is already available. So if you look at the questions, we have so many set of questions in GC. We are also explaining each and every JVM flag that is helping you to improve performance to some extent, especially from the JVM side or the application server side or the deadlocks optimization side. We'll go talk each and everything into a very deeper level where we'll do something like a spoon feeding. We're going to talk about what is object, what is method, example of an object, what is JVM, what is JRE, what is JDK. All these things are very discussed in detail. That is why the reason we are taking 45 to 50 sessions of time. Else we could have completed all these things at a very high level, showing some PPTs, giving you some rough bottlenecks, something like that. We can do that and we can give you, we can close it in 3 weeks, which will not help you or which will not help the organization. I mean, whatever from wherever we are actually conducting the sessions. For your understanding, for your question, I got you what you are trying to ask. If you're taking something like this, we have some problematic things. I mean, we have some snippets which are going to simulate. As no one knows how a memory leak will look like, how a out of memory, how a out of memory error is going to happen. We are going to show you something like this. We have a memory leak examples. We are going to provide all these details to you. Out of memory error. If you see, if I am getting disconnected from the Zoom link, I'll connect again. Not to worry much, I'll show you some example. Task manager, if you see the performance of my machine, it is 8.5 currently utilized, right? Now I'll show you how.
screen share got stopped actually.
Sorry,
I am not able to see your screen. Oh, okay, I can see. Sorry.
you're able to see.
Yeah,
So
yeah.
if you see my memory utilization now, it is 8.5, which is 54% of my available memory. If you see memory leak or out of memory leak, if you see, I say profile as, I'll click on Java application. I'll tell you how I integrated this JProfiler tool with my IDE. I'm directly doing code profiling with my JProfiler. If I click on OK, now you can see the resource utilization. If you can see 9.4, 9.5, 9.6, it's continuously eating all my available memory on my server. If you can clearly see that, 10.2, 10.3, at some point it reaches to 15.8 and it is going to eat all the available memory and it is going to throw out of memory error. Okay, so something like that, we are going to show you for each and everything. The normal
Okay.
behavioral pattern of heap.
Simulating.
Sorry, you're able to hear me? I
So
stopped
we
it.
will be, I mean, we will be getting this.
I stopped the sharing.
Okay. So we will be basically giving, I mean, we will be getting this code, right, to simulate
Yes,
in our
you'll be
machine
getting this code.
and try and test it out.
You'll be getting this code, you'll be able to practice, you'll be able to see the heap utilization. If you see, this is the normal pattern of heap utilization, which is also called sawtooth pattern. So the memory gets utilized, the GC is going to happen here. It will reclaim the memory, it will come back to 0. Again, the objects come and fall in heap, the GC runs. I mean, the memory utilization happens during, for whatever the time the objects are running and allocating the memory, the GC happens here. And you're going to free up the memory. It's going to free up the memory. This is the generic pattern of, I mean, the actual behavior of heap. But if you see something like this, okay, which means that the memory is being constantly utilized, this is an indication of memory leak, okay? And it is going to eat all your memory. And you can also see, if you take the JProfiler, where is it? If you take the JProfiler, we are also going to give you some set of softwares. I'll tell you what softwares they are because the session is recording. These sessions, these things comes with the default demo servers installed. So as soon as you click here, it is going to give you some simulated activity with the help of demo servers. You can also see here, you can click on leak connections, and if you click on start database activity, it is going to tell you how the memory is getting utilized, how the GC is happening, how many classes are loaded, how many classes are unloaded, what is the nature of threads here. Okay, so if you can see clear drop, if you see this drop, because this drop happened, the memory has been reclaimed here just because the GC has happened here. Okay, if you go to the heap poker, you can take multiple heap snapshots from here. Okay, by selecting all the types of references. Okay, if you click here, you're going to get the heap dump. We're going to tell you how you need to analyze a heap dump. Practically, how to take multiple heap dumps, how to analyze them, what are the things that you need to look at. All these things are, especially things like heap dump, thread dump, are going to take 3 to 4 days of time. GC is going to take 4 days of time. Application deployment, installation of web application server, database server, creating a SQL server scripts, how to completely connect your application code to the database, how to configure, everything will be talked in detail. Okay, so what is a thread pool, what is an application pool, what is a connection pool, all these things will be shown in a real-time manner on the WebLogic server, on the Apache Tomcat server. And coming to the database server, we are also going to show you how databases are working. A simple example is, I don't know, 1 minute, please. If my server is, yeah.
On database, would you be explaining about Oracle database? Because that's, I think, licensed, no?
No, we don't, will not teach to the extent where we are going to avail the license, but we are going to tell you how to take AWR report, how to take ADDM report, how to take ASH report. Example, what are the things that you need to look at. If you see here, Oracle PM. I'm telling you one point right from the beginning, right? What is required for a performance engineer?
Right. See, RK, the thing is, why I was interested in the time duration was that I'm not at a beginner level in performance testing or performance engineering. But I'm not at that expert level where I would get every option to explore everything, because projects often have limited area to work in. So that's why I was more interested in how much time would I have to spend on this course. So you're saying it would be like roughly 2 months, and that would be 1 hour each day on a training session and about 1 to 2 hours self-study, right?
That depends, because if you are very much aware of all these concepts and if you have so much of experience in performance testing, then it would take less time comparatively. But whatever the topics that we are showing it to you, 70% you see them as new. I can guarantee you that, because There are lot many things which you need to explore. For example, if you take JVisual VM, JProfiler, JMC, JFR,
Right, right, right. I've seen all these, but I do not know what is the information. I don't know how to interpret it, because there are KRAs for development teams, engineering teams, and infra teams. So I'm just from the testing team. I do get to see them, but I do not get to interpret them the way a performance engineer should. So I'm not that out of touch of it. It's all about how much time would I have to spend, because my work schedules are very hectic.
Mhm. I would say, I mean, the first 20 sessions would be most of the basics and all, but when it comes to advanced concepts, you would start looking at the course content at least some 30 minutes or 60 minutes, because whenever I learn something, I put it on 1.5x speed, and if I'm very much familiar with the topics and all, I go like that. But there are few concepts like example, database performance engineering is the place where you have to spend a lot of time.
Correct, correct.
.NET performance engineering, most of us don't do it. Java performance engineering is what is frequently asked in many of the interviews, until and unless a company like Dell Technologies, which is having all their applications on .NET, they are going to ask only on .NET. They don't touch Java in the interviews. That's the reason people with Java experience giving interview to a company like Dell, where you have everything in Java, you don't get selected. So it depends on what the requirement they have, what is currently you're working on, and what is that they are looking for. That's the point here. So when it comes to interpretation is something that is more important. And if you take all the common JDs across USA, UK, clearing the interviews in India has become more difficult if you compare it with US and UK. UK itself is having only 2 to 3 rounds, but whereas Salesforce, ServiceNow, VMware, all these guys are taking 7 to 8 rounds here in India for a performance engineer. So it depends on how things are taken up. Some performance testing assignments are asked for VMware, storage domain. SAP Labs takes people have experience only in SAP performance testing. So things work differently, but interpretation of the results, it depends on how you spend your time. If you already have some 8 to 10 years of experience, if you already have some 50% of experience in all the end-to-end performance engineering activities, comparatively, it would take less time for you. But some people from the beginner level who are looking for this sort of training, example, last batch out of 26 people, 18 people we gave to one MNC straight away because they got trained in all these areas. That's the generic requirement. So it depends on your requirement again. Okay.
Okay.
So I told you, right, coming to techniques to analyze thread dumps, how to identify performance patterns uh, using thread dumps, Java thread dump techniques tools, and coming to GC logs, how to analyze GC log, something like Imran, you have a question?
Yes, okay. As you said, like we'll be taking care of like client side and server side monitoring. So I got one more question, like what about the network side monitoring nowadays? They ask for
We are giving you the complete installation of one of the famous networking tool, because I'm not supposed to disclose this name. This recording will be uploaded. So network performance optimization, network performance management, we're going to explain you that.
okay.
Okay, extensively network performance monitoring, because AppDynamics, Dynatrace, they don't do dedicated network performance monitoring. A tool like SolarWinds network performance monitor is going to do network performance monitoring, which is going to monitor all the switches, routers, devices, everything. So it'll also tell you all the metrics. We have a separate sessions for that.
Okay, so as you said, like you gave away on my second question, you gave second 18 members to straightforward MNC. Like, do you after this session do you refer to people like us we having some around the starting 4 to 5 years of experience? Okay.
We get multiple requests from multiple companies. As soon as you are ready with your learning, we directly push your profile there.
Okay.
They schedule the interview, they take your profile. That's how things are working from the last couple of batches.
Okay, sure. Thank you.
So I mean, we don't charge anything for that, but it's something like it's all depends on how the candidate is getting prepared.
Oh,
So also differentiating the difference between the memory leaks, out of memory errors, how do they happen? What are the reasons for memory leaks? In a field code, understanding, taking a deep dive into code level errors, understanding the code profiling. You have something like architectural design phase, understanding the architectural components. Then we are going to teach hardware sizing in depth, where we are going to decide what is the size of environment, what is the amount of CPU, memory, hard disk latency that is required on a database server in performance testing environment. So none of us are actually doing performance testing, which is as same as prod, right? Not even a mirror image of prod, which is not exact replica of the prod. If you go back and check all your performance testing environments today, half of the components that are available in prod environment are now missing. Why WhatsApp is down? Why Insta is down for so long time? Very recently, because of DNS failures. If you go back and look at your performance testing environments today, you don't have a concept of implementation of DNS or CDN. There is no existence of CDN or DNS in the environment that you're testing. How many people joined? 12 people joined. Go back, check all your performance testing environments today. No existence of CDN or DNS is found. So half of the performance that you are seeing in performance testing environment is not accurate. The way you are doing it in your performance testing environment is wrong. But considering the line customer is got, doing what the customer meeting what the customer expectations that he had as per the various business demands, we are in line, and we are doing only that when we are working with many of the services based companies, right? So whatever the environment you take, example, take a performance testing environment database, take a production database server. If a production database server is having 70% of the database CPU utilization, if you come back and see your database in your performance testing environment, you are not even having 21% of the utilization. You know the reason why? Because the production database server is shared with many applications. It is going to run backups. It is going to have recoveries running. It is going to have batch jobs running, and it is going to have multiple applications there. So if you come back and see your testing database server, testing environment database server, it becomes active only when you're doing load testing on it, because all these things are not simulated. Can you place your call on mute, please? Thank you. It is getting unmuted. Okay. So what I'm trying to tell you is understanding the gap between the production environment and performance testing environment should make some sense while publishing the results. Testing around 1/4 size of prod. Okay, production environment is supporting 100 users maximum capacity. You don't have that budget, so you have 1/4 size of prod where you can test only with 25 users. Now, can we say the customer that if you got the results for 25 users on 1/4 size of environment on prod in QA environment? Now, can we tell directly to the customer that whatever the results that you got, multiplying it by 4, can we say that it is going to work with 100 users like this? You cannot tell like that. Extrapolation of the results by not testing on the actual environment is completely invalid. Okay, considering the performance prod environment, having every single instance of every component must be available in order to replicate the actual performance testing. You should have CDN, you should have DNS, you should have if you have multiple API servers in production server, at least 2 if you have 8 API servers in prod, at least 2 API servers should be a part of your dedicated performance testing environment. If you don't have API servers in performance testing environment at all, the processing time that is being spent on API servers in prod will be ignored in the environment where you're actually testing, and the response times that you're getting are wrong. The way you're doing performance testing on the environment like this is completely inaccurate, and it doesn't make any sense. So you have a lot of other performance degrading activities like GC, understanding the GC logs, exclusively GC monitoring, understanding the memory related problems. For all the memory related problems, you need to take one to many heap dumps. For all the related deadlocks, high response times, high resource utilizations, you have to take multiple thread dumps. So when you see high response times for all the GC related issues that are increasing response times, resource utilizations on the web application servers, database servers, you have to take multiple GC logs to find out what exactly is creating the problem. Okay, that is what I'm completely explaining you here. We can do code profiling from the IDE side. We can do code profiling from the application server side. We can do code profiling by invoking the application from the browser. There are so many ways where you can do the code profiling in multiple ways. Okay, that is, we're going to deal with multiple tools: JVisual VM, JMap, JSTAT, JHAT, Heap Hero, Fast Thread. So all these things will be taken care. In the same thing, we are going to talk about real-time application performance issues. This is where we're going to talk about some of the realistic problems that we have encountered from the practice side, from the excellence side, and cross-transferring the bottlenecks the participants have. We're going to raise something like a discussion, and we're going to talk about all the bottlenecks, how it created the bottleneck, what is the root cause, how we fixed it, what are the metrics that helped. All these things we're going to talk here. Here, in addition, we're going to talk about how to do efficient scaling. Okay, on what basis do we do scaling? Okay, what is the use of scalability? And also talking about all the network other related parameters which are creating the performance problems. We'll show everything on a real-time application that is deployed, and we'll close it. Okay, so if you see here, JProfiler, YourKit, JVisual VM, Redgate, Ants Performance Profiler, all these things, Dynatrace, CA. Lakshmi, do you have any problem with your mic? It's continuously getting background noise. I don't know, I mean, it's not able to respond. All right. So coming to the profilers, you have CLR profiler, you have MEM profiler, you have tens of profiling tools that we are covering as part of this course for Java and .NET as well. Your Kit profiler and JProfiler are the most commonly used profiling tools that are going to help you in all the different ways to identify the performance bottlenecks and how to apply various techniques to fine-tune Java applications. Optimizing all these things will be taken care. For everything, you're going to get the complete documentation, troubleshooting guidelines, root cause analysis, what are the action items that you need to take as a performance engineer, how to interpret the results is covered as part of this entire program. That is the main key point here. And .NET Performance Engineering, it is the same thing as Java. Like we have JVM in Java, we have CLR in .NET, where we're going to talk about big list of performance metrics, how the .NET performance problems to happen, what is badly implemented thread safety, thread synchronization, like Java memory management, like GC. You also have GC. You also have heap memory in .NET, like young generation, old generation, and metaspace in JVM Java. You have small object heap and large object heap in .NET. Coming to the GC algorithms in .NET, you have server GC and workstation GC, which are the two main GC algorithms in .NET, which are going to make an impact of the performance when we are using these two different GC algorithms during the application .NET application load testing. We also have GC related problems. We also have .NET CLR related problems. We have GC past tense, all these things, unnecessary logging. Coming to the .NET, right? Especially .NET has, when you take a Microsoft product, right? Microsoft is going to use IAS server, IAS Web Application Server. Then as a Microsoft SQL Server is a database server from Microsoft, they are going to use that. When they're moving all these things to cloud, Microsoft is officially taking Microsoft Azure as cloud, where they're going to use Azure App Sites, Azure App Insights as their monitoring tool, inbuilt monitoring tool. And there is also called Azure Monitor, which is an inbuilt utility, which is going to completely monitor all the activities of the assets that are provided by Azure Cloud. Okay. Same thing happens to the AWS. AWS has CloudWatch, which is an inbuilt monitoring tool for AWS Cloud, but it is not that it is going to give you all the things that you need. Things like CA, APM, New Relic, Datadog are much required to monitor all the cloud instances, and each cloud instance has got a big list of metrics to see how they are getting utilized, how we can interpret the results. All these things are there. So the last one is the database performance monitoring. This is where we are going to primarily talk on AWR report, primarily on Oracle database, AWR report, Oracle Enterprise Manager, how to take ASH report, how to take ADDM reports. Even even a person like Oracle DBA who is having 15 years of experience in database administration, sometimes it is very hard for him to identify the performance problems by looking at the AWR report. AWR report is so huge, and there are only some key sections that are required for every performance engineer. It's not that you need to become a master or you need to know each and every single line that you see in database monitoring. So database monitoring, database understanding for a performance engineering context is limited here. You have to understand that point. So you have so many AWR reports. If you look at the AWR reports, you have example, you're able to see my screen?
Yeah.
Simple thing is, this is a default SQL script that you already have. Once, as soon as you run this one, enter the report type. If you go select the report type, and if you give something like 2 days or something, it is going to give you all the snap IDs. Okay, you have so many snaps available. If you want to know the database health, database statistics, you can go here and you can give the snap as 2897. The beginning snap from 8:15 to 4:30 if you want to take. 4:30, the snap ID is 2903. So again, you have to give all these details like this. You have to give the name. You can see the Oracle database instance name, and you can see that database report is getting created. We'll talk all of these things later. But this is something like you have to go there, take multiple AWR reports. What is the frequency of taking AWR reports? How to analyze interpret the performance problems. Definitely the database administrator interpretation is required to conclude and derive what exactly is the problem. Which section is creating the problem? For example, parsing. Hard parsing is bad. You should not see high number of hard parsers. To understand hard parsing and soft parsing, to understand parsing, you need to know how a SQL query is executed inside a database. We're going to teach that basics, because during the process of SQL query execution, it is going to tell what is the problem. Okay, where exactly it is spending most of its time. Fine-tuning the SQL query is also not possible directly, because if you are understanding the problematic query and directly trying to fix that, it will change the entire execution plan of the other existing SQL queries which are already working fine. So as soon as you as soon as you identify SQL query, after fine tuning that, you have to initially test that on a test database first. Okay, the reason I'll tell you, if you're directly implementing that fix on a production database server, what happens is that particular fix that you have implemented on a prod server, there are chances where it can show some negative impact on the other executing SQL queries execution plans, which are already working fine or executing as expected. Okay, so we're going to talk about AWR report, ASH report, ADDM report, how they are useful, what you can see. And the last one is, sorry, some of the things are missing here in this one. So I don't think so. And seeing some data. So I'm sorry if you missed the data. Basically, not only Oracle database, we are also talking about MySQL Server. Okay, so we're also talking about SQL Server. I'll show you simple example before I close the session. We have some servers available where you have already connected everything. Okay, so did we close that? Okay. So we are covering MySQL database. We are covering SQL Server database, and we are also covering Oracle database. And coming to this one, we are NoSQL databases. We would like to give you some high level overview on the Cassandra database, sorry, Mongo database, where we don't have application to connect. Okay, we will not be able to connect to that application, so which will be a little problem. So we're not connecting to that, but we'll give you some high level session. Okay, high level session on what exactly is going to talk about NoSQL database. Will some of the topics will be highlighted from the serverless computing. Okay, some of the topics at a very high level will be cache session will be taken care of. What is cache? How do you implement cache? All these things will be taken care. So you need not worry much about all these things. We are going to talk about each and every single parameter that is part of your this thing. But from the Oracle last thing, if you see here, we have only Oracle, but we have also have MySQL database. We have SQL Server databases. We have multiple reports for that. All these things are available. And coming to the client side, this is where we are spending some of our time. Importance of client-side performance testing, common performance problems. What are the things that you need to look at? GTmetrix, something like this. If you go to GTmetrix, and if you run something like redbus.in or whatever, when you test it, what are the things that you need to look at? How you need to optimize the client-side performance? How to minify the JS calls? How to minify CSS, how to compress the images, okay, how to put multiple HTTP requests in one bundle, compress it, how to improve the response times is what we are clearly explaining from the content that we have shown. Okay, putting JavaScripts down, putting JavaScripts up, reducing the DNS lookup. All these things are something which will be covered And finally, like I said, like the way you take lot of like the way you do lot of things in real time, you'll be able to do all these things in environment. We are creating a lab setup. We are making the participants to create their own lab setup where they can deploy the application, where they can debug the code in Visual Studio, Eclipse IDE, where they can profile the code, will give monitoring tools, profiling tools, everything will be given. And finally, it's will make you ready for any complex interview. That is the end result of this course. The end result of this course would be getting a very good job with huge pay with, I mean, you'll be able to clear any complex interview. Okay, that's the main agenda. And after this, we have a separate course. For that, this should be something like a prerequisite. We have a containerized performance testing where we have real-time microservices-based application, which is connected to Prometheus, which is sitting on Docker Kubernetes, connected to some cloud. So we would like to also tell you some CI/CD pipeline. That's a different course, which is not part of this one. It is able to start in a month or so. Maybe in the December month, it is going to start. We would like to teach everything on a real time. Okay, it's not just theoretical, it's always practical. And you will also get so many questions. We are going to clarify all of that, and we are going to provide whatever the documentation that is required to all of you. All right. That's all for today. Thanks all of you for joining.